Hello again and welcome back. We are going to be covering types of bonding in this section. Covalent, ionic, and hydrogen bonds specifically. We're not going to focus on metallic. So previously we learned the difference between an atom, a molecule, and a compound. Now we're going to discuss what types of atoms cause what types of bonding. So first question of importance is, why do atoms bond together? Now this is to achieve stability. Stable atoms have full outer shells. The first shell usually contains 2 electrons, and the second to fourth shell hold 8. We're not going to go any further than that, but there are elements that have more than 4 shells filled. But for now, we're going to focus on shells 1 through 4. And what do I mean when I talk about shells? Well, each atom, if you remember, has a center nucleus, and around that center nucleus, there are bands of electrons. Each band is full of a certain number of electrons, and once that band becomes full, the electrons move to the outer shells to fill them up as well. Now, the first shell, as I stated, holds 2 electrons, and the second through fourth hold 8. And atoms will bond to other atoms if they're missing or have extra electrons. They want to be stable. They are stable when full. It's like having a great big meal and just feeling perfectly comfortable right afterwards. Not too full, not hungry, you're just content. That is what they're trying to achieve, contentment. They don't like being empty or overfilled. So, for instance, I'm going to show you 2 examples of 2 atoms and their atomic shells. So let's start with neon here. Just a disclaimer, my ability to draw with the mouse pad is not the best, but we will work through it. So, let's make this my little nucleus. And neon has an atomic number of 10, so that means 10 protons, approximately 10 neutrons. So then we're going to create this first outer shell. This first outer shell is going to have 2 electrons, because that's how much it can handle. Now, we started with 10 electrons, because for every number of proton, there's an equal number of electrons, if you remember. So we started with 10, we lost 2, we're now left with 8. So we'll draw another line around. And we can fill this up with those 8. Now this is a content atom. It's full. Its outer shell is perfectly content. Neon is one of the noble gases, and you'll find with all of the noble gases that their outer shells are actually perfectly filled, and they're not ones to react very much with other atoms because of that. You're going to have a hard time getting the noble gases, neon, argon, radon, not wanting to really mess with anything else. They're pretty happy by themselves. They're full, they're content, they don't want to be messed with. It's like after a long meal and a long day, you want to be just left alone. That's them. Now, carbon is a little different. So, carbon, which is represented by a C, here's my little nucleus, has an atomic number of 6. Now, as I stated, the atomic number represents the number of protons and electrons and potentially neutrons in a perfect world. However, that's not always the case, but it does usually represent in a normal atom the number of protons and electrons. So, we have 6 protons, 6 electrons. So that first shell is coming right here, and it can only hold 2, so we're going to put 2 little ones in there. There we go. So we have used up 2, we're now left with 4. So we have 1 more shell, and here's a problem here. 1, 2, 3, 4. It's not full. It's not even close to full. It's halfway filled. So carbon is one of those unique atoms because of its halfway filling of that final shell, where it's going to do everything it can. That outer shell. It's either going to get rid of the extra 4 or it's going to try and find 4. It has equal opportunity because atoms are going to want to do the easiest thing for them. So if they have 1 or 2 extra, they're going to prefer getting rid of those extra instead of finding, say, 6. If they have 7, they're going to look for an extra 1 instead of giving away 7. So the goal is to fill up that shell as easily as possible without any extra effort, because that's energy and they don't have that to really give. But carbon doesn't care. Carbon has 4. It can get rid of the 4. It can gain 4. Carbon is actually an incredibly useful atom for this, and that's why carbon's able to make so many complex molecules, and especially the molecules that make up us. Carbon is very versatile. Carbon will latch on with anything that will take it. So, we've covered those. Let's start talking about bonding. Our first type of bond is a covalent bond. This is a sharing of electrons to achieve stability. This is usually found in nonmetals, so the right side of the periodic table. This is when they're both latched on. They don't want to let go completely, so they're only partially sharing to fill the shells. These are incredibly strong bonds. So I'll give an example of this. So I have my 2 little fluorines. And my fluorines have 9 molecules. So let's go ahead and draw their first shells, because we know their first shells are going to be full, because they at least have 2 electrons, because they have 9 protons in each. Okay. Now, let's draw their second shell. So let's draw the last of the electrons. Since fluorine has an atomic number of 9, we've already used 2, there are 7 left in each shell. So I am going to just do a big old dot there instead. A little easier. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. They are missing 1. So what's going to end up happening is they're going to each share 1. They're not going to let it go completely, but they're going to share 1 here and 1 here. And they're going to form a double bond between these 2, bonding them together. So they're each sharing 1. Therefore, they can't let go or else they're unhappy. Now, atoms that can be involved in this, you're either going to have something like carbon that's half full and some almost full atoms that are willing to share with carbon, or 2 almost full atoms like the fluorine. This, because of the sharing, creates a very strong bond. This is the strongest bond we're going to be talking about in this class. And I want you to remember this because I'm going to bring it up second semester stuff. It's going to keep coming back. This is a very strong bond. This is what holds a lot of the components of your molecules together, keeps the backbone of your DNA from falling apart. It's an incredibly strong bond. Ionic bonds are when you transfer electrons between atoms. So you're not sharing anymore, you're giving or taking. This is again to achieve stability. They want to be full and content. We usually have a metal and a non-metal mixing together here because the non-metal is usually almost full and the metal is usually almost empty in their outer shell. So let's look at an example of this. Perfect example is sodium chloride. Sodium is a metal, chlorine is a non-metal. So let's draw this. So I'm going to draw that first outer circle here to show the nucleus. My little sodium nucleus, my little chlorine nucleus. Okay, now I'm going to do my first outer shell for both. One and two. 1 and 2. Now, sodium has 9 and chlorine has 15. So I'm going to draw the second outer shells for both of them. And for both of them, it's full. So they have 8 in each. 1, 2, 3, 4, 5, 6, 7, 8. Now comes the tricky part. Their finer outer shells are lacking. So they each have 3 electron shells here. Now, if you did the math along with me, there's already 10 electrons. Sodium only has 1 left. So it has 1, just 1 extra. Chlorine, if you were doing the math, has 7. So that's a problem. Neither of them are content. In order for them to become content, somebody has to give up something. And I doubt it's going to be chlorine, because chlorine's almost full. Chlorine's not going to give away all that. The more it gives away, the more discontent it will be, and it will take longer for it to be content again. Sodium, however, only has a little bitsy one. So what will happen is sodium will gift chlorine this little one right here. And now both are content because sodium's outer shell is now the second one and it's full. Chlorine has 3 outer shells, all full. They're both content. This is usually only the case when you have an almost empty and an almost full atom. This is a strong bond, but definitely not as strong as that sharing covalent bond. We're going to stop right here now, and we're going to talk about hydrogen bonds last, and we will work on that in the next video. And then we'll wrap up bonding. Talk a little bit about ions and isotopes as well. So I hope that made sense to you. Let me know if it didn't, and we'll touch back with hydrogen bonds next.